Today we're going to be solving logarithmic equations that have logs on both sides. And the property that we're going to be using today says that if log base b of x equals log base b of y, then x equals y. If the logs match on both sides, if there's a log on both sides and they are the exact same log, same base, then the stuff inside the logs must be equal. So in number 9, log base 4 of 3 equals log base 4 of 2x plus 5. Because they are both log base 4, that means that 3 must equal 2x plus 5. So 3 equals 2x plus 5. How would you solve that equation? Minus 5. So negative 2 equals 2x. Divide by 2. X equals negative 1. Number 10, ln of x squared minus 4x equals ln of 12. Because they are both ln's, that means x squared minus 4x must equal 12. How do we solve this kind of equation? When you have x squared and x in the same equation, you need to get 0 on one side so that you can factor and solve. So we will subtract 12 on both sides so that we have x squared minus 4x minus 12 equals 0. So we want to get one side equal to 0. Next, we want to factor. Now, some of you are really, really good at factoring. Some of you are still terrified of factoring. If you are terrified of factoring, come see me before school, after school, or during Wildcat Hour. I will work with you on factoring, and I will help it to not be scary, because it should not be scary. We are going to keep using it over and over in this class. When you factor, if it's plain x squared, it's going to factor into x plus or minus something times x plus or minus something. Those somethings are determined by two numbers that multiply to give you negative 12 and add to give you negative 4x. If you need to write out the blanks, blank times blank equals negative 12, blank plus blank equals negative 4. If you visually need to write those blanks out to help you see and help you test numbers, go for it. But a lot of you can now move beyond that into just kind of guessing and checking. I like to put a multiplication symbol above my negative 12 and an addition symbol above my negative 4 just to visually remind me of the pair of numbers I'm looking for. So if it's going to multiply to be 12, it'd be like 3 times 4 or 2 times 6. Which one's going to give us negative 4? 2 and 6. To get negative 4, the bigger number needs to be negative. So it's x plus 2 times x minus 6. Your next step is to solve. Remember, if x plus 2 equals 0, one of our solutions is x equals negative 2. Our other solution is x equals positive 6. Remember, you're looking for the x value that would make the set of parentheses equal 0. So negative 2 plus 2 would give you 0. 6 minus 6 would give you 0. So negative 2 and 6. Did anyone see up above where it says check for extraneous solutions? Extraneous solutions are solutions that appear to work algebraically. They come through as solutions in the process of solving the equation, but when you plug them back into the original equation, they may not actually work. It's really important to check for extraneous solutions when you have two answers. Really, if you have more than one solution, it's really important to check for extraneous solutions. So let's check these. you check them back in the original equation. So plug -2 in. -2 squared is 4, so we'd have the ln of 4 minus 4 times -2 is +8. Does that equation look like it would work? ln of 4 plus 8 equals ln of 12? Yes, that works. So that is a solution. Now let's try 6. ln of 6 squared is 36. Minus 4 times 6, that's minus 24. Does 36 minus 24 equal 12? Why, yes, it does. So both of these solutions actually work. On number 11, the first thing that I would like you to notice is that there's logs on both sides, but how many logs do we have on the left side? We have 2 logs on the left side. We really want there to only be 1 log on the left side. So we need to condense this logarithm. So a plus sign between the logs, what does that mean when we condense them? It means multiplication. So we are going to condense this into log of x plus 2 times x minus 3 equals log of x plus 29. So that step, what we did was we condensed the log. Now we're going to use, I'm just going to call it the log equals log property. So because it's plain log on both sides, that means x plus 2 times x minus 3 is going to equal x plus 29. Anyone want to take a guess what we're going to do next? We are going to distribute. Hold on, I'm going to move this so it's a little bit more. Yeah, I don't like that word. I don't like the word foil. You like the word moist? We are going to distribute, double distribute, foil if you must call it that. Expand is actually the correct term for it. Now, you can use your factoring rules, your factoring shortcut to help you multiply this out. This is going to be x squared. The middle term is the result of adding these two numbers, so that'll be -1x. The last term is the result of multiplying those two numbers. That will be -6. If you need to show your work and actually do x squared minus 3x plus 2x minus 6 and then combine your like terms, go for it. But as you get more familiar with factoring, you can use those factoring shortcuts backwards to help you multiply it out. Your next step, because we have x squared and x in the same equation, is to get one side equal to 0. So we are going to subtract x from both sides and subtract 29 from both sides. That will give us x squared minus 2x minus 35 equals 0. Your next step is to factor. Now, I know that this problem is fairly labor intensive. It looks like we got rid of the logs, but then we had to multiply it out, and now we're trying to factor it back again. It's like we're stretching it and compressing it and stretching it and compressing it over and over and over. That's what we're doing, but that's the process for solving this type of equation. So when we factor this, we are looking for two numbers that multiply to give us 35. What are some options that do that? 1 times 35 and 7 times 5. So if we do 7 and 5, to make it be -2x, the bigger number would need to be negative. Our solutions, what would be our solutions? -5, +7. Okay, your next step is to check your solutions. And remember, we are checking our solutions back in the original equation. So here's what I'd like you to do. Let's start with this first x right here. plug negative 5 into that x. What is negative 5 plus 2? So we'd have the log of negative 3. Can we have a negative number inside a log? No. So that immediately creates something that we can't do in the calculator, so that's not an answer. Don't do more work than you need to. If you get a negative number inside the log, stop. That solution doesn't work. Okay? Let's try 7. There are some instances where both solutions don't work, so we do still need to try 7. So 7 plus 2 is 9. We would have the log of 9 plus 7 minus 3 is 4. So we'd have the log of 4 equals the log of 7 plus 29 is 36. And you could either plug that into your calculator or use your condensing rules. Log of 9 plus log of 4, that'd be the log of 9 times 4. Is 9 times 4 equivalent to 36? Yes, it is. This works. X equals 7 is a solution. Our first step in number 12 is to condense. And what I see is on the right side we have two logs, and they are connected with a minus sign. What does a subtraction sign between the logs equate to? Inside, it equates to divide. So this is log base 2 of x plus 5 equals log base 2 of x minus 1 over x plus 1. Then, using the property that we're talking about today, x plus 5 is going to equal x minus 1 over x plus 1. Now, here's the problem. How the heck do we do this? Okay. You can multiply both sides by x plus 1 to get rid of the division, or think of this as a proportion, x plus 5 over 1, and then we're cross-multiplying. We end up with x plus 5 times x plus 1 equals x minus 1. And then we would go to this step. We would distribute, get 0 on one side, factor, solve, and check our solutions. Do you want to try finishing this one on your own? Okay, finish this one on your own. In about 30 seconds, I will put the answer up here. When you distribute and get 0 on one side and factor and solve, you end up getting two negative solutions. Now, there is a misconception. A negative solution does not necessarily mean that it doesn't work. There are some negative solutions that will work. But in this particular log's case, when you plug the negative 2 into this x right here, it creates log base 2 of a negative number both times. And since it creates log base 2 of a negative number and we can't do that, neither of the solutions work, so no solutions. It is possible for both of the solutions to not work. It's also possible for both of the solutions to work. It's also possible for only one of the solutions to work.